Dr. Bill, thank you so much for coming on the show. I'm really excited. You are like a legend in the space of anti-aging. So I'm very excited to have you here and ask you a bunch of questions about how we can live forever.
Well, please call me Bill. I never pursued a medical degree, PhD or MD. I uh, just ended up getting one as a result of trying to learn everything I could about the aging process.
Excellent. Well, I'm excited to dive into that today. So can you just give us a little bit of background on like your educational pursuits and how you came to be like the father of telomere biology?
There's actually a good documentary called The Immortalists, where it talks about answering that question. Because I really, I became obsessed with trying to study the aging process when I was only 10 years old, because my father was really interested in that. And so the reason I just mentioned that documentary called The Immortalist is because my father is in it, uh, explaining how he's always been interested in aging. But he was, when he realized that I was really interested in science and medicine, because I'd get notes pinned to my shirt from my teachers when I would come home from school in elementary school, saying, "Hey, your son's interested in, is obsessed with science and medicine. You should nurture that." Well, so he, and he already knew I was really interested in science, because one year I wanted a telescope for Christmas, and they gave me a telescope that was kind of like a toy telescope, and I cried. Okay, so they put me in the car and we went to like uh, open houses where people were selling garage sales and things like that, and they found a really nice 4 foot long, 8 inch reflector telescope that I just became obsessed with at 10 years old. I would be out every single night looking at inside craters on the moon and moons of Saturn, rings, moons of Jupiter, rings of Saturn, things like that. So my father came out to the front lawn one day when I was 10 years old and said, "Bill, since you're so interested in science and medicine, when you grow up, you should become a doctor and find a cure for aging." And he said, "I don't know why nobody's done that yet." Okay, now why my father thought aging was something that could be cured, I don't know. Why he thought it was the disease, I don't know. But I didn't realize I didn't really realize that a lot of people didn't think of it as a disease and something that can't be cured until I was actually in my 40s. Okay, I always thought is something, some plague that affected us sometimes. So it's like something we inherited. Because why would everything I, even as 10-year-old, I was starting to understand evolution. Why did we evolve something called aging? Why didn't we ever evolve a way not to age, since aging is bad for us? And I now know the answers to all those questions. But let's say I'm 99% certain I know the answers, because there's no way to ever prove anything. But I mean, I've been able to figure out from all the biological mechanisms and stuff that we know about that aging was unavoidable. And the survival of our species depended upon it. I know I'm getting off subject here, but I know we can come back to that again later. But the my father got me obsessed with it, and so I I became the kid in school that was always talking about curing aging. High school, things like that. I actually started anti-aging clubs in high school and college and graduate school. Um, there are like present Nobel Prize winners that were actually part of those groups. And like a guy named Bruce Beutler, who got the Nobel Prize in medicine in 2011, I think it was.
Wow.
He he was somebody that he and I were like best friends, and we were obsessed with the whole idea of what aging is, and we wanted to cure it and things like that. And so we actually did experiments together with fruit flies to try to study the aging process.
Interesting.
But so it's been an obsession of mine. Uh, but one of the things that I did all through my schooling was figure out what courses that I needed to take to really understand this, and that's what I did. I just studied everything I could, because it became obvious to me that there were a lot of theories on why we age and how we age and things like that, but none of them made sense, because it didn't explain everything. None of them explained everything about aging, um, especially like why do humans die of old age at one age, but dogs die of old age at a different age? I mean, there had to be something, there had to be some kind of clock that was existing inside of our bodies or our cells that was different between dogs and humans. Because it can't be just the environment. Why would dogs and humans age differently when they're in the exact same environment? There were all these kind of things, but we came up with this idea back when I was still in college, um, that there had to be something like ride tickets at an amusement park inside of our bodies somewhere, that we lost a ticket every once in a while. I mean, they had to be inside of our cells, because there couldn't be, we couldn't imagine a biological mechanism that would be as sophisticated as a ticking clock or something like that. It had to be some type of process that, like so Leonard Hayflick had discovered in 1961 that cells can only divide a certain number of times. And that ended up, in my opinion, and my anti-aging club's opinion, that that had to be something that had something to do with aging. And so how would a cell know how many times it has divided, how many times it has left to divide? The only thing we could come up with that could be a biological relevance was ride tickets in an amusement park. So I spent next 10 plus years trying to figure out what those ride tickets at an amusement park could be. And that's when I learned about telomeres. And I thought, okay, here it is. These are the ride tickets that control our aging process. And so even though I study all aspects of aging, all mitochondrial dysfunction, oxidative stress, inflammation, all these kind of things, I've come to the realization that no matter what else we do to cure aging, we'll never cure aging unless we also solve the telomere shortening problem, because that is a hard, fast limitation on our lifespan that is completely understood now. We understand every mechanism of how it works, why it works, everything like that. We got to solve that problem, but that doesn't mean that it's going to be the solution to everything. It might be we got to solve that one, and then we still have to solve the other problems too.
Find the next answer. Yeah. So I think that like we know a little bit about mitochondrial dysfunction. We know a little bit about oxidative stress, but telomeres are like that's a very interesting field of study. Can you pretend for a second that I'm like 6 and explain to me telomeres? What are they? What do they do? What's the shortening process? How's that determined? Like shortening our lifespan, and then talk about telomerase and like what it was like when you discovered that and how that plays with telomeres.
With telomeres, they're found at the very tips of our chromosomes, and it's a DNA sequence. That's DNA. Our chromosomes are made up of DNA, and DNA is made up of 4 different bases units, like beads on a string, and it's a sequence of those bases that tell us what our hair color is, or our eye color, things like that. But at the very tips of our, so think of this long string of beads that are make up our chromosome, and typical chromosomes about 100 million beads in length. The beads are called bases. But think of this long string of beads as a shoelace. And at the very tips of your shoelaces, you have these caps called aglets that protect your shoelaces. Okay, well, our long string of beads also have caps at the very tips called telomeres. And they are actually protecting our DNA from degradation by a host of different things, environmental things, and also internal things that can affect our DNA. So we have these caps, but they're not just protecting the DNA, our chromosomes, they're actually controlling gene expression on our DNA. Okay, so in a typical DNA molecule, 100 million bases long, you have thousands of genes. Okay, the genes are given our hair color, eye color. Every gene next to it has a dimmer switch that turns the gene on and off. And it's the change in, so that's called expression.
When we're talking about gene expression, could you also say epigenetics here?
Yeah, I was going to say it's the study of epigenetics, okay, which is the study of turning genes on and off. So our epigenetics changes. So when you take cells from a young person, a middle-aged person, and an old person, you find out that their epigenetics are different. they find out that some genes are turned on more or less than others, depending upon age. And so there's been a lot of studies. In fact, we published a study in the 1990s, I think one of the very first studies, looking at a survey of gene expression, epigenetics of associated with aging. But it turns out that telomeres actually play a role in adjusting those dimmer switches. And it does so by the same way that enhancer sequences, which is something somebody who's experienced in biology, science, and DNA would understand. But enhancer sequences are sequences found throughout our chromosomes that seem to have an effect on the dimmer switches, even though the dimmer switch might be 10,000 bases away from the gene. And it does so by folding over. So proteins will bind to, proteins called transcription factors will bind to the enhancer. They'll fold over, come in contact with proteins that are bound to the dimmer switch, and it'll turn that switch on or off. Well, telomeres do the same thing. Telomeres have all the hallmarks of enhancer. They fold over, they come in contact with dimmer switches on your chromosomes. The difference between a telomere and a regular enhancer is that the telomeres get shorter, okay, every time a cell divides. And so it can't reach as far. And as a result, you have age-related changes in these dimmer switches. So we're just trying to control that. That's the big thing. It's like telomeres are playing a role, not just in aging, but even all the other biomarkers of aging, like DNA methylation and IgG glycosylation and all these things. Nobody knows exactly. For instance, DNA methylation is something that's correlated with aging, but nobody knows how the DNA methylation changes occur. Okay, until we started realizing that it's telomeres. Telomeres are affecting the expression of genes called methylases, and methylases are actually what are methylating the DNA. And same thing we can say the same thing for IgG glycosylation. We can say the thing for grip strength, vision, all the different things you know about aging, wrinkles in your skin, vision problems, heart disease, cancer, all these things. They're very, very associated with telomere length, but telomere lengths aren't the only things that can cause things. Okay, so when I first, I've been looking for this system that could be analogous to ride tickets at an amusement park. And when I first heard somebody talk about the fact that telomeres shorten as if they were ride tickets at an amusement park, and every 40 bases is essentially equivalent of one ride ticket. So every time you lose 40 bases, it's like losing a ride ticket. And I keep going on tangents, but the loss isn't from wear and tear. The loss is from every time a cell divides, a new DNA molecule is made, but our cells lack the ability to duplicate the original DNA all the way to the end. So the new DNAs are made shorter. They're not shortened by wear and tear. But so that makes it like you can look at the length of a telomere and you can figure out how many times that cell has divided, because every time it divided, it lost the ride ticket.
Okay. So I feel like at some point in there, you forgot that I was 6.
Yeah. Well, I know. So, I don't know how to. Sometimes I don't know how to do it, but I'm trying to explain. But
you did good with the shoelace thing. I'm getting that. So like if I could kind of like think about how I would explain this. So the shoestring is the genetic material. The shoelace, like the end of the shoelace, is the telomere. As those duplicate and they go through their natural cellular like replication process, every time they duplicate, they get shorter, which is how we know how much someone has aged. Is that about right?
Yeah, except that there is an analogy that I use that everybody explains. Sometimes to explain the analogy, I first have to be a little scientific, but the analogy is, think of a brick wall, okay? You have a top row of bricks on a brick wall.
Okay.
And think of that top row of bricks as your DNA. Okay, so your cell's about to divide. Everything inside that cell needs to be duplicated so that the daughter cells have everything the same as the parent cell. But that includes that DNA. Okay, so now cell's about to divide. A bricklayer has to come along and layer a new row of bricks on top of that brick wall. except that in our cells, that brick layer is standing on top of the wall, walking backward, laying a brick, taking another step backward, laying another brick. And when that brick layer gets to the very end of the wall, the brick layer falls off without being able to add a brick in the very tip of the end. So that's what causes telomere shortening. It's not a wear and tear. It's the lack of the ability for the cell to put a brick in the last place.
Okay, that I'm tracking with that. That makes a lot of sense.
Okay, so the question that really came. So I learned about this in early 1990s, and
Okay, so I'm a little
before
late to the
that
party.
speaker could even get off the stage, I was there asking, has anybody figured out how to re-lengthen telomeres? Because one thing I've learned is that in order to prove that something's happening, you got to reverse it. And has somebody figured out how to lengthen the telomere after it's been shortened? And he said, no, we've been working for years on it. We have labs all over the world that have been working with us. Nobody's been able to figure it out. And I just flat out said, let me come and work with you and I'll have it figured out in 3 months. And sounds kind of bold, but I'd already had a pretty good career with developing a lot of the biotech breakthroughs that exist. I'm one of the inventors of human growth hormone, erythropoietin, beta seron, tissue plasminogen activator, and that's only a fraction of them. So he'd offered me a job on the spot. And 3 months, 17 days later, I discovered this enzyme called human telomerase. Okay, so before I go into detail, the way I discovered it was, I said to myself, if every time a cell divides, the telomere gets shorter, why is it that our children are born with longer telomeres than we have? That didn't make sense, because production of sperm and eggs requires cell division. And so the telomere should get shorter every time those cells divide. So our reproductive cells, also called the primordial germ cell line, they had to have some way of preventing telomere shortening. Otherwise, our children will be born older than we are, or with shorter telomeres than we have. And after 300,000 years or just a few thousand years, we would be extinct as a species because we wouldn't have any DNA left. So my focus was to find out, what do our reproductive cells have that our other cells don't have? And we ended up discovering this enzyme, which we call human telomerase. It had been discovered earlier by some scientists studying a pond scum organism called tetrahymena, but they had never connected the dots to it being anything to do with aging or cancer or diseases or anything like that. So we discovered this human telomerase, and we put it into normal skin cells and showed that it completely stopped their aging, plus it reversed their aging by every method of measurement you could imagine. And we repeated this with treating human skin growing on the back of a mouse. And then other scientists, because I don't really work with animals, other scientists did this with engineered mice that had been engineered to age like humans do by telomere shortening. And so in all cases, they saw reversal of aging by every method of measurement imaginable. So that was my big mission at the time. Now, I was already National Inventor of the Year for my cancer research, okay, because I had developed a lot of cancer drugs that had been through clinical studies, and some got approved and some didn't. But I had already a strong cancer background. So one of the things that I did was, can we kill cancers by doing what's called the antisense of telomerase, this enzyme telomerase, to accelerate the aging of cancer cells and make them die of old age really quickly. And so we did those experiments, and we found out it worked really well. And so now there's a lot of cancer drugs on the market that actually work by inhibiting this enzyme telomerase. Now, that doesn't mean that telomerase caused the cancer. Cells had to become cancer first and then cure their own aging by producing telomerase. In fact, if we put telomerase into normal cells, it actually decreases the risk of cancer. So
oh, really? I was gonna ask about that. If that actually would increase the amount of cancers you see or the growth of it. But
no, Actually, there's a really good YouTube video of me talking at a conference in Tokyo in 2017 to an audience of about 500 doctors, where I go into the most extensive detail about showing that telomerase actually decreases risk of cancer. It's short telomeres that cause cancer, and long telomeres decrease the risk of cancer. Um,
Okay. So I guess like this sounds great, and I'm like, what an exciting thing to have discovered. But I think the thing that everyone is probably wondering right now is, where can I get some telomerase? Is that like, do I find that in like a kale smoothie? Like, how do we get that back inside of ourselves to prevent this aging process?
Well, that's the mission of my life right now, is trying to
Yeah.
figure out ways of producing telomerase. Now, we have been able to do it using techniques called gene therapy, which
Okay.
is where we essentially deliver a new gene to the cells, and that produces, then that gene has the dimmer switch permanently set to the on position.
Okay.
So those cells produce telomerase. And that's how we've been able to show reversal of aging and all those things I mentioned before.
Is this fall in line with like CRISPR?
CRISPR's a way is a well, gene therapy is the delivery of the CRISPR machinery to the
Okay, got it.
cells. Okay,
I mean, kind of
CRISPR
got
is
it. I don't really
gene
have it, but
editing. Yeah, Chris, and I've been doing gene editing since the 1990s too, using what are called zinc fingers and talons. CRISPR is just the newest version of gene editing. It's
gotcha.
just gotten a lot of good marketing, stuff like that. But it's actually, gene editing has been around for a while.
Okay. I mean,
But
obviously, you did talk about a mouse with human skin on the back, which I just glossed right over. But yeah,
yeah, so yeah, that's that was actually done by Dr. Walter Funk, who worked for me when I was still at Geron Corporation. He grew human skin on the back of a mouse, which gave a really good way of studying humans biology in terms of telomeres.
Hmm.
But the I lost my train of thought.
I was asking you how do we get more of it? You said
Oh yeah,
this is your life's work, putting it like figuring out how to get more of that into people's cells using some like genetic editing. What's
delivering a new gene to the
Yeah.
cell by gene therapy is not that's a risky thing to do. So gene therapy isn't really ready for human use yet, and plus it would have to require a lot of FDA clinical studies to get it ready for use, and those are in progress. But what I always thought was, if our reproductive cells can produce telomerase, that means they have the gene for telomerase. And the dimmer switch is turned on in our reproductive cells, but turned off in all the other cells of our body. So why not just turn the dimmer switch back on in all the other cells of our body? And so I've been testing, you know, chemicals, mostly nutraceuticals, plant extracts, looking for anything inside of a plant extract that, when you consumed it, would get inside your cells, bind to the proteins that are regulating, that are shutting that dimmer switch off, dislodge those proteins to allow the gene to turn back on. So that's what 95% of everything we do here at CR Science is all about, is finding things that will bind to what's called the protein that shuts the dimmer switch off. It's called a repressor protein. Things that will easily get in, so small molecules, so it easily get inside the cell, bind to that repressor protein, dislodge it to allow the gene to turn on. So we've been working on that. We have these $1 million robots that can test up to 4,000 different plant extracts or chemicals a day, looking for anything. Our limitation is actually more funding than actually testing, and actually getting a hold of it and enough things to test. So the robots can do more than we can. So we don't actually test 4,000 a day, but they can test up to 4,000 a day if we had enough things to test.
Okay. So is that kind of where we're at right now? Is like, we know this exists. We know this exists in our reproductive cells. So you're either looking for two different options, ways to genetically insert like telomerase into like cells themselves, or find something that like on a higher level where we can actually flip that dimmer switch off and start you like reproducing our cells in an exact fashion rather than shortening them. And that's kind of where we're like, that's like the thing that's kind of stymieing us right now. That's the next big hurdle to be overcome. Or do you have answers for those things?
No, that's we are working on. Well, first of all, the gene therapy is going to take 15 years before it would ever be approved by the FDA if we got it to work correctly. But what we've been testing, so we have found a lot of different plant extracts that actually do dislodge that repressor and turns the dimmer switch on a little bit. Nothing turns it on yet as much as we find in our reproductive cells.
Got it. But you're getting close.
Yeah.
What are some of the compounds or the type of plant compounds that we can actually start using?
Repeat the question.
Where what are you seeing that is working to turn that dimmer switch off just a little bit?
Well, the ingredients in this new product called Telovital, a company called Touchstone Essentials licensed our top nutraceuticals, the most potent nutraceuticals, and they put them into this product called Telovital. And those nutraceuticals turn on that dimmer switch better than anything else on the planet right now. That includes like turmeric, but so these aren't total plant extracts. No total plant extract works because a plant extract is made up of probably 100,000 different chemicals. Okay. And so some are going to inhibit the activity, some are going to enhance the activity. So we have to fractionate, separate in chemicals that are in a plant by size or charge or solubility, all the different kinds of things. And we get a lot of what are called fractions of plant extracts. So we found that turmeric, one fraction of turmeric actually induces that dimmer switch to turn on. And then we found out that that particular fraction was missing curcumin, which was kind of a surprise because we thought curcumin might be something that would be one of the benefits. Turmeric is a really good product, but mostly because of curcumin. But it turns out curcumin is not the thing that induces this telomerase gene to turn on. So turmeric minus curcumin, because curcumin turns out to inhibit actually telomerase. There's a few studies that have shown that too. But there's also fractions of plant extracts from several other things like pomegranate's one of them. Another one's called hazy. But again, the whole plant extracts don't work. Okay, you have to use the fraction. So the top fractions have been combined into this. I can't even remember them all because we've tested close to 20,000 different plant fractions of plant extracts, and we've only found 40 that work.
Wow.
And so the top 5 are in. And the reason why we mixed 5 of them together is because I'd mentioned there's a protein that binds to the dimmer switch. Well, we believe that the gene that produces telomerase actually has more than one dimmer switch. It requires more than one type of protein to shut it off. So we have to what's called de-repress more than one. So hopefully mixing 5 different together is de-repressing more than just one. So we're still in basic research. Okay, we're finding the best things we can. The good news is because they're plant extracts and they're already generally regarded as safe by the FDA, they can be put into products right now for people to start taking.
Okay, cool. All right, so we're on the path. You got a couple things that are working. We got some research in development right now that will help us find more things, and you got robots who are helping along with the whole process.
Yeah, and we're nonstop. I mean, there's going to be a next generation of Telovital, and then a next generation after that. It's just going to get better and better as we find more and more potent things.
Okay, so let's talk about like common longevity hacks that we see. Like number one, I want to know what the biggest myth you're seeing in like sports science, pop culture right now from a longevity perspective. And then I want to hear a little bit about like fasting, cold plunges, different supplements, and how much of that actually moves the needle for telomere health.
I would say the biggest myth that I encounter all the time is somebody saying that they've got a product that reverses a biomarker and then says that reverses aging. And that is, there's not a single thing on the planet yet that reverses aging. Okay. And I mean, when somebody goes into their doctor's office and says, "Oh, I wish somebody would make a product that would make me younger," the doctor might say, "Well, here's a product that will uh, make you younger, but it's actually only maybe giving you more energy." Okay. And let's say something like NAD. Okay. Or, nicotinamide riboside, which is my favorite for producing in higher levels of NAD. I think of other things like there's resveratrol, things like that. But they don't actually reverse aging. They just reverse a biomarker that may have nothing to do with aging, just correlate with aging. But the symptoms might be because of some other environmental thing that had nothing to do with aging. So, so the biggest myths are that there are products right now that reverse aging. That's not true. There's only products that will reverse some of the biomarkers that correlate with aging. But nobody has been able to show that they have anything to do with aging. And so when I speak at medical conferences, I say nothing really reverses aging until somebody passes what I call the Betty White test. Okay. And so I will show pictures of Betty White when she was 25 and when she was 85. And I'll just say, does anybody here not know which photo was taken first? And I mean, it's like, and then say, okay, so how do you know? Well, nobody really knows. I mean, it's a qualitative kind of thing. It's like, I mean, we can remove wrinkles from Betty White's face in the photos. We can remove fat from her face. We can change her hair color, but people would still know which one was taken first. And it's like aging is so complicated. There are so many different factors. It's like, walking down a street and looking at people of the opposite sex or same sex, depending on who you are, and who's the most handsome or beautiful or something like that. Well, how do you know? How do you determine that? That's a qualitative thing that's somehow built in. There's so many different factors that are involved. Same with aging. So even though we can't say why we know which photo of Betty White was taken first, there's no question of the fact that we do. And so I say, if you have a product that you are claiming reverses aging, where are the people that pass the Betty White test? And nobody has anything that has passed the Betty White. Nobody on the planet has ever passed the Betty White test. There's one exception. That's a woman named Liz Parrish, who's actually been experimenting with gene therapy on her own. She may have passed the Betty White test because I've seen her and she definitely looks younger than she used to be.
I have a similar test. It's called the monkey brain test.
Yeah.
It's when people put up supplements and they're like, this supplement or this compound or this polyphenol or whatever is responsible for more muscle growth than anything else. And you go, well, in like the 70s, bodybuilders were sneaking into rhesus monkey labs and eating the brains to get a little bit of extra growth hormone. You think if there was something that they could simply just buy off of like store shelves, they wouldn't have already been doing that. Like we would have known. So
I think you can't eat growth hormone and expect it to get inside your cells to work. Remember, I'm one of the inventors of human growth hormone. So I know
outside of the like the moral gray area, and also like even if that's effective, like we've got people who are so obsessed with building muscle that they've tried literally everything. If you thought that doing a single rep that took you 60 seconds was actually the key to building excessive amounts of muscle, I'm pretty sure we'd know about it by now. Yeah. So I like little like thought experiments like that.
The biology of muscle building is so complex that everybody's going to be different. Nothing's going to work for everybody. And anytime somebody starts saying, "Oh, it worked for me," they think it's going to work for everybody, and it's just not going to happen.
And also like it's also a slow process. I think a lot of people like see these transformations before and afters and stuff like that, and they're like, "Oh, I'm just going to build some muscle." When in reality, it's like a 10-year, 20-year game. Losing fat's easy. It's fast. You can do it pretty quickly. Building muscle, that is a lifetime endeavor.
Going on a tangent here, there is also one thing. So building muscle is a good example of accelerating aging. Okay, because
talk about that.
Yeah, so the way muscles get bigger is you cause damage to the muscles, tears and things like that. And then the tears get filled from cell division. And as I said before, every time a cell divides, the telomeres get shorter. So by doing a lot of like muscle bodybuilding, you are actually accelerating telomere shortening, therefore accelerating aging. And but I
It
always
also
say,
increases cellular oxidation and like total body stress too.
yeah, and stress and inflammation both accelerate aging too by different mechanisms. Now the same is true for microdermabrasion. When you treat your face with acids or lasers, you kill cells, other cells have to divide to replace those cells. You look younger for a short period of time. I call it a boost of youth, but it accelerated aging. Same with
Interesting.
immune.
You gotta take it from yourself. You can't. It's not free.
Yeah, right. It's
That's
like
interesting.
it's same with immune boosters. You're causing immune cells to divide, and that's accelerating aging. But here's the thing: is I always say, what's the point of living a long time if you're not living? Okay, so
Health span
if
versus lifespan. Yeah.
building muscles and making your face look younger is important to you, then continue to do it, because count on me to have a solution. Okay,
I love that.
I'm going to continue my research until I actually have something that actually will let somebody pass the Betty White test. Then it'll be available to everybody. And so if you have already accelerated your aging from growth hormone or building muscles or microdermabrasion, when we have something that produces enough telomeres to actually re-lengthen the telomeres, that'll reverse all those effects.
Well, I want to build a lot of muscle, so I need you to work a little faster.
Yeah. I've always said that too, but I just know that genetics, no matter what I do to build muscles, I can't do it.
So I got a couple more questions. Number one is, what are the things that we are doing currently that are accelerating aging that might not be healthy? Like, I think that largely more muscle is going to result in a better quality of life, if not maybe a longer life, just because muscle is a very metabolic tissue. It helps us process glucose a little bit better. What are the things that we're doing that are not healthy or don't have health benefits that are accelerating the aging process? And I know we know about smoking.
Yes,
Know about
smoking was the
drinking.
first thing I was going to say, actually.
Yeah,
Smoking,
like
obesity, psychological stress, pessimism has been published to be accelerate aging. If you don't think you're going to live to be 100, you're probably right. And why, I don't know. I just know that people like Elisa Epel, who's one of the top people in the psychology of aging, has had done some research or has referred to other people's research on showing that pessimism, psychological stress, things like that accelerate aging.
feels like a quantum physics type of situation there.
And there's lack of exercise. Lack of exercise accelerates aging. And then also exercise that's too intense accelerates aging. Okay.
Okay, you're an ultra marathon runner, aren't you?
Yes.
So talk about that. How does those things correlate, or is that something you do because you love it?
Well, no, I think that ultramarathon running slows down the aging process if you do it right.
Really? Okay.
Yeah. So the rule of thumb is do endurance exercise, whether it's running, kayaking, bicycling. It doesn't matter what it is, but keep it fun. Okay, as long as you can quit when it quits being fun, because and then do it consistently. And if you are like using running as an example, if you run every 2 weeks and then enter a marathon, you'll probably do well, but you'll be stiff as a board for 2 weeks. Okay, because of all the inflammation that's going to build up in your joints and stuff like that. Your body's thinking, oh my God, what's happening to myself? And it's going to start inducing an inflammatory response, sending immune cells to your joints. That causes swelling and stiffness and things like that. But it also causes accelerated aging, especially by accelerated telomere shortening. So I always say, run consistently, run every day, okay? But keep it fun. And when it quits being fun, quit. Save it for another day. And after a while, you're going to find out that you can run every day and never, ever have any inflammatory problems, never have any inflammation biomarkers increase. And that's actually good for you. And it's slowing down the aging process. I actually used to hold the world record for the most 100-mile races run in a year. Okay.
Whoa.
I ran 12 of them, but I quit in 4 of them because it quit being fun. Okay. And I finished 8, which actually was a world record at the time. And when I would run 100 miles, the next day I could go out and run 20 miles without any problems. Okay. Because I kept it fun. I did not, and I did studies where I was taking blood samples from runners, not just myself, but other runners too, before, during, and after races. And I was measuring inflammatory markers. I was also measuring electrolytes because I was also trying to figure out what the proper electrolyte things are to do. But I would find out that people that were just keeping fun, talking, running together, running 100 miles, but talking with each other during the whole time, their inflammatory markers were always low. Okay. And, yeah, so I did hold that world record, and I think I couldn't have done it if I had been one of these people that was obsessed with having to win the race, and crossing finish lines on my hands and knees, throwing up and things like that. I did it for the fun. I speak at endurance conferences a lot, and I'll say, if you're a runner, a bicyclist, or something like that, and get out in nature, find trails to explore, and get off trail. I'll say, if you see a coyote, run after the coyote. It'll drive it nuts, but it'll take you to places where no humans have ever gone before. You'll get adventure like nobody else, even if it's in your own backyard practically. But those are the kind of things. So keep it fun, keep it adventurous. I actually now am approaching my 2000th consecutive day of running every day.
Whoa.
Of 2 miles or more at least. And there's people that are up to 50,000 days. In fact, the world record is going to be broken. I forget the guy's name, but in like a week or 10 days from now, the world record for most consecutive days of running is going to be broken. And it's something like 50,000 days or 50 years. Maybe it's something like that. But
wait, 50,000 days is 136 years. That's not possible.
Yeah, so it can't be 50. It had to be 50 years. I could, and anybody, if you just do.
By the way, you don't look anywhere close to 136. You're doing great.
Yeah. If you do a Google search, just search for running streak. Okay. You'll find a website where people are keeping tabs of how many days they have run. That's where you can see whose person is who's about to break the world record.
John Sutherland ended his streak December 31st of last year after 55 years, 7 months, and 6 days, allegedly.
Because of heart problems. Because of heart, but that's going to be broken. And I'm only at 2000, which is a little over 5 years of not missing a day. I did miss a day on April 9th, 2020, and it devastated me. I thought, oh my God, I have to start over from zero. And so running streaks, I recommend them because psychologically it makes you afraid not to go out and run every day because you get this streak going and you don't want to start over like I had to on April 10th, 2020. And that's so April 10th, that's the beginning of my 2000 consecutive days.
Gotcha. So I'm like 29th. Keeping it fun, having something that psychologically keeps you motivated to do it. But I'm also hearing that when you do something frequently like that, whether it's weight training or swimming or biking or running or whatever it is, your body becomes more adapted to that stimulus. And therefore there's less of an inflammation response, which is going to aid you in anti-aging versus a higher inflammation response leading to more aging, which is where we see like a lot of runners who look older than they actually are.
Yes. Running is like a Goldilocks effect. Too little intensity or too much intensity accelerates your aging. In the middle is it's good.
Awesome. Bill, this has been really fascinating. A lot of stuff to keep in mind here. A lot of things that I'm looking forward to hearing back from you in a couple of years and seeing where you're at with telomerase and how we're be able to get more of it. But in the meantime, like how can people follow along with your projects and your processes before we go today?
I actually, since I'm just a medical research company, right in the wall behind me, on the other side of that wall is 10,500 square feet of labs. That's all. Okay. So we only do research here. We don't market or anything. And, when we find something that actually does induce telomerase, we just put it on the shelf because we know we're going to find something even more potent like 2 months later or something like that. So it's not, but companies like, there's been several companies that I haven't been really big fans of, but I really like Touchstone Essentials. They have higher ethics than almost everybody else in the field. So they asked if they could license some of our top nutraceuticals from us. And so we said, okay. And so they created Telo Vital out of it. And I've really enjoyed working with this company because, especially the founder, a guy named Eddie Stone, I think Touchstone is named after Eddie Stone. He's only interested in making people happier and healthier. He's not interested in like, what do you call it? Profit margins and things like that. And so which is really good because that's all I'm interested in, is making people happier and healthier. So Touchstone, even though I'm just a research company, I don't keep my website up to date. So it's probably not, people can go to my website, which is www.sierrasci, SIERRASCI, short for Sierra Sciences.com. And they can find a lot of stuff there, but they can also find a lot of stuff on Touchstone Essentials website. And that's www.thegoodinside.com. No spaces, all one word. And so they're doing a lot of stuff right now with me, and they're actually the ones that organize this podcast with you too, because I don't market, but I do talk about the science, and I think that there's YouTube videos where I do explain why a lot of companies do think they have something that reverses aging. And I'm not saying they're lying or anything like that. I think they just misunderstand the process. Okay, but I explain all that and how to know what really does work and what doesn't work and things like that. And you can find my YouTube. Well, people can also email me. Okay, and I don't mind giving out my email address. I actually love spending time taking a break from the science and stuff like that to respond to people's emails. My email address is B as in boy, Andrews, so BANDREWS at Sierra Sci, again, short for Sierra Sciences.com. And I can send people videos of me talking about what aging is, why we age, how not to age. And it's based on a lot of like education in not just biology, but evolution and statistical theory and things like that. And I've got it all together in terms of why we age. I can tell you exactly why we age in these videos would explain that. And I can tell you how we age. And it's like different than everybody actually thinks, because everybody's based on the common theories that exist that don't make any sense. But I've got it all analyzed. If somebody really wants to know why we age, or more importantly, why did we never evolve a way not to age, I can explain that. That's explained totally in my videos. And then how we age. Aging does begin with wear and tear, but we're not trucks sitting in a field that are exposed to wind and rain and sun and things like that have wear and tear. We are different than old trucks because we have cells that can divide to replace the damaged cells. Okay, and so why do we age? Well, we age because our cells can only divide a certain number of times. Just like drinking alcohol kills liver cells, you don't experience any problems when you're young because you have plenty of liver cells to divide to replace those killed liver cells. But when you get into your 40s, suddenly you run out of cells to divide to replace those damaged liver cells because of telomere shortening, and you get liver cirrhosis, which is an accumulation of dead cells, and it kills you, okay, because your liver quits functioning. But there's all kinds of things like that I explain in these videos and stuff like that. So yeah, but that's where they can get more. But I would go to the Touchstone Essentials first, because they're building a big summary of everything that I do and talk about.
Very cool. Well, thank you so much for your time today. Thanks for dropping some wisdom on us. This has been fascinating stuff. Really appreciate you.
All right. Thank you.
All right. Talk to you soon. Have a great rest of your day.